Say welcome everyone. It's good to have everyone joining us again. We didn't have a July experiment share because summer's pretty busy, and as you'll see, it's not a huge crowd, but it's still a very diverse crowd here. I think we have people joining from about 10 different countries, even though there's only like 12 or 15 of us. So it's always great to see how many different people from all over come along. I myself am at the wine harvest in Corsica. I think my second camera right now, Sarah's showing you some vines, so I'll spotlight that for a second before turning things over to Gordana for the first experiment. And as long as there's no hiccups in the order, I'll finish off with my own experiment. So I know if things have got a bit quick, I'll go shorter or go longer if there's more time. Just before we get started, if anyone feels like saying hi, either in the chat and say where you're from, or if there's few enough, feel free to turn on your mic and say hi that way as well if you prefer. And then we'll switch over probably to Gordana in Požega, Serbia. Okay, so Gordana, if you're okay to start, can we turn things over to you to start with the first experiment? And you're mute, so you'll need to unmute yourself before starting. If we don't hear,
is it okay?
Yeah, now we hear. Okay, perfect. Great. Okay. So now we'll turn things over.
Thank you. Nice to see you, all of you again. Thank you for calling, for inviting me. Thank you very much. Here I have some several lenses, as you can see. I have some convex lenses, convex, and I have some concave lenses. So I'm going to show you some very simple experiment with two pairs of lenses, same focal length they have, and they are placed at distance, and we are going to see the effect of invisibility. So you can put them on this. Those are the formula. Here I have focal length 1 and focal length 2. And you can take this in a video, Michael.
To show the video from your students now?
Yeah, but no, after this.
Okay.
And I put them here. Here and here. I will take it easy because my camera is not so good. Here's my clips. Can you see this?
When the direction changes, there's a bit of a lag before it's in focus, but yeah, like we can see the lens in the clip there now.
Okay. Yeah, in the clips, yeah. And I took here 75 centimeters, and another one on 177 centimeters, and again 75 centimeters. And now I'm going to show you the effect of invisible. It's going to be very hard for me. Now my camera is not good. Michael, can you explain, please, this?
Sure. So the idea here, to recap, there's 4 lenses, and it's a symmetrical arrangement, where the focal lengths are such that it'll reproduce an image on the other side where the lens appears more or less invisible. So as long as it's clean, it's kind of hard to see that the lens, like there's something on the other side. But with the optics of it, near the midpoint, you have all the light passing through the focal point of the second lenses and the midpoint of the setup. So you're able to pass objects across the diameter of the lens. And as long as you avoid the very fine, like midpoint where all the light is focusing through, you won't be able to see that the object's there. So when it's lined, it is finicky to line up on camera. It's a really cool effect, but when it is lined up, Gordana should be able to pass her finger or an object between the lenses, and it'll look like her. No.
Yes. Yes, I can take it, but very hard with my tablet to catch it, you know. But thank you for explanation.
Oh, with pleasure. And I think the effect was more clear on the video you sent me earlier. Do you want me to show that as well?
Okay, or with a small focal length, smaller focal length maybe. I have several, but not right focal length. I have them all in school, but not now. I'm here. I'm at home. Summertime. Sorry. Okay, but this is the formulas for length, and that's all, Michael.
And the last two lines, the Zhizhina, the Lina.
Yeah, great, great. It's the Cyrillic letter, great. It's the focal length, and T is the distance between. T1 was 75 centimeters, and T2 was 177. Is it okay?
Yeah. Oh, that's why it's such a long setup. That makes sense now.
Kids like this very much in optics to do.
For me, it was all very clear, but I've done a similar experiment before. Do people have?
And I also saw the explanation with mirrors. It's very, very nice.
So do people have any questions or anything to add for Gordana's experiment?
Oh, Michael, your Serbian is good. Žižna daljina. Yeah.
Yes, very much.
Žižna daljina. Yes.
Okay. Good. Very nice.
It's a lot easier to read TypeScript Cyrillic because handwriting, I never exposed to that. Whereas like when trying to learn on apps and stuff, it's all typeface. So it's hard to go between the two. But I'll get more practice in a couple of weeks.
You know Cyrillic.
Yeah, I just don't know what most of the words mean, so that's the next step to come up.
Oh, it's great.
Great, very much. Thank you all.
Thank you.
Of you. Thank you.
Oh, then thank you, Gordana. So Astrinos, do you think things are ready now, or do you need another minute to try and sort things out?
No, I think I'm ready now. Hopefully,
excellent.
Everything was planned. We'll see.
Yeah, and we hear you loud and clear. So we'll switch things over to you. And I think I mention every time, Astrinos is the only one who's presented every single experiment there so far. So he always gets the VIP. I mentioned that he's been there every single time. And the first monthly one was in his lab in Crete last November. So great to have you back again, Astrinos.
I think Paul only missed the Crete meeting.
Yeah, that's true. I should always mention Paul too, because he's always been there except one, I think.
So as long as she was not invited or couldn't be here, she's also one of the founders of this experiment share.
That's a very good point. So thank you for bringing that up, because it's always great to see Paul always enthusiastic to support us as well.
Yeah, yes. Well, okay. So tonight I had planned to show you Well, this is a water bottle launcher, but I'm not going to show you this experiment because I have, I think that next time I will offer a simplified version of this launcher, something that as a little workshop, something that everybody can do and use with the students. This can launch a water bottle to a distance of more than 150 meters. So it's pretty impressive and maybe somehow dangerous, but okay, I love rockets. I have hand-launched rockets, rubber band launched rockets, carbon dioxide, of course. And today I decided to offer the version of an alcohol-based rocket, because it makes some nice noise when it is launched, and well, my students love it, and it's not it's impressive and not as dangerous as the water bottle one, because it doesn't build a lot of pressure inside. We start with just one of these plastic nightmare bottles, because we cannot ever get rid of them if we keep on using. I don't think they are recycled in an effective way. I used the cap and drill a hole of, well, what made sense after a few experiments is that a 6 millimeter hole is just enough, not a lot smaller, not a lot bigger, just 6 millimeters. And of course, you don't need a drill bit to make a hole. And then I put some alcohol, maybe a few minutes before the experiment. So there is enough time to have alcohol vapor inside. I use this is 95%. This is only used for medical purposes. You cannot, it's not the expensive type for drinks, I mean. I leave it enough time just to make sure that I have enough vapor inside. Usually it doesn't take long. And then, of course, I show my students what happens if I just light some of the liquid, which is not very impressive. It burns very slowly. And of course, and it's almost transparent. You cannot see the flame very easily in daylight. But here I will just, I don't need the alcohol inside. I only need the vapor. Of course, I make sure that some of the liquid is outside to help me light all the vapor inside. Now it's almost empty. I will put it in here, and hopefully everything will go as planned. And I will light my lighter. As you can see, this is empty now. The only thing that can be inside is alcohol vapor, and of course a lot of air. So I light the lighter and ready for launch. Well, the distance is more than 8 meters because it was stopped by the wall. Paul, ouzo content, alcohol content is not enough, I think. It's merely a 40 to 45%. But if you ever come to Greece, or I might bring some to Berlin, and we'll try together.
And Serbia, Rakia.
Like we have raki here as well from grapes.
40%.
Yes, 40 to 45% here. The same.
Though I'd say having tried homemade versions of both, often it seems like it's stronger than 40%. So that was great, Astrinos. Does anyone have any either comments like Paul did, or any questions for Astrinos? And just a heads up, Erno in Hungary will be up next. So while we're seeing if he has anything to say for Astrinos, hopefully Erno will be getting ready. One thing I have to add is the 6 millimeter hole. That seems to be about the magic number for an experiment I picked up from Paul with surface tension. Those of you who've been to probably maybe the May experiment share might have seen that. I forget which one, either he showed it or I showed it that he had shown me. But if you have a hole about that size in the cap of a bottle and you turn it upside down, the water can stay in from surface tension and you can pass things through. I don't have one prepared because that wasn't what I was planning to show, but 6 millimeters, like for the one from Astrinos, seems to be, for me, when I've been trying that, although I've never measured, it's always what I can do with a knife or a pair of scissors or whatever I find lying around. Does anyone have anything else to say about Astrinos' experiment before we move on to Erno in Hungary? I think that's it then. So turning things over to Erno, and he's actually one of the last people, or like most recent people I visited, who showed me a bunch of experiments. And so I think it's going to be two of the ones that he showed me when I was with him in Hungary. So it's great to have you along. Thanks for joining us to show these, Erno.
Hey, hello everyone. I'm Erno. I'm from Hungary. Can you hear me?
Yeah, we hear you well.
Cool.
Yes.
All right, because I had to turn open on the mic, and I'm never sure if it registers or not. Okay, I have two experiments that I really like, and I guess you can do that at home as well. You need a 3D pair of 3D glasses for the one, or you pretty much need one that you're willing to just break and actually use the filters that are in, because I mean, I'm pretty sure that most of your more like all of you knows that the 3D glasses have polarizing filters, and that way your two eyes can see basically different films. So you can play with it, that if you have the two glasses, for some reason, I don't know why, you need to have the glass or the halves of the glasses facing each other in a way like you would fold it. And then if you have it oriented the same way, you can see through them. And if you start slowly turning, the visibility is reduced. And about 90 degrees, which is like what we expect, the visibility just ceases to be there. And there is, I mean, there is some refraction, but that's it. I've never showed it through the webcam, but I guess there is also the fun in that. What I usually do is either I put it in front of my eyes, or I just hide a finger behind it. Depends on how many hands I have, and then I can just play with it. If you have polarizing filters in a bigger version, I'm pretty sure you do that as well. But I mean, the fun is that you only need the 3D glasses, and if you have enough, or if you can convince the students to bring some, they can also play with it. If you have two, I don't have two unbroken, but if you have two, you can just use the two without actually breaking them. So that's also a possibility. And it's something that the students can try it at home as well. And even, I mean, if it's advanced, you can talk about angles as well. And there is a, I mean, it gets gradually black depending on the angle the two are facing each other. So that's one. I hope it's new to someone. And I have to go to the kitchen for the second one. So here comes the fun part. I'm really trying to switch to my phone, and I'm not sure how it will work, and I'm just hoping. So give me half a sec.
Of course, and while he's switching, and it looks like he may have dropped off for a second. While we're waiting for him to, oh, there he is. Okay, so and you're mute for the moment, Erno.
Cool. I mean, am I on mute now?
Yeah, you're on mute now. Now we hear you well.
Cool, cool. I mean, Zoom has a switch devices button, which is amazing. I think I should be able to switch the video as well. Nope, not what I was looking for. Yep, this is what I'm looking for. Okay.
There we go, yeah.
You need this, I mean, that's the fun part. We just call it in Hungary energy saving light tubes. And as I've been researching the English name, it's fluorescent something. Michael,
yeah, often it's called a compact fluorescent, maybe light. It's CF something. I think it's CFL. Someone jump in if it's something other than light that the L stands for. A lamp, okay, thanks, Paul. But yeah, because it's a fluorescent lamp that's compact.
All right. So you need one of these. I mean, it can be, not broken, but if the ignition is broken and it won't function as you intend, but the tubes are intact, that's amazing. You need a glass of water. I mean, you just need enough water that it will cover the metal part, because we are going to put it in a microwave oven, and you probably don't want anything metal in your microwave oven unless you're ready to kill that microwave oven. What we don't need, and I totally forgot to remove, is the rotating parts. And if you have a microwave oven that you're not using for anything else, you can kill the lights already inside for more dramatic reasons. I'm usually just stealing the microwave oven from the chemistry department because they have one and the physics doesn't, but it doesn't really matter. So the fun part is that I believe the lamp is filled with mercury vapor or something like that. It's on low pressure. So if you just turn on the lamp, the ignition just is going to excite the particles, and it will emit, I think it's ultraviolet light, and then the phosphorus white powder on it will be the one who will just gonna be using phosphorescency or phosphorizing, not even sure what the word is.
Yeah, phosphorescence.
All right. So if you turn on the microwave, it needs a second, but you can perfectly see as the lamp is turned on. Then when you turn off the microwave oven, it's gone. So, I mean, pretty much the microwaves can excite the gas inside the compact light something lamp. So in this, what I also love about this experiment is, like, there are always people who are really afraid of the microwaves escaping the microwave oven. So you can just show them that you turn on the microwave oven and you have the lamp just in front of it, will not light up at all. So everyone can relax, and the microwaves are staying inside the microwave oven. And since you have a microwave oven with you, I'm not sure if that's visible on the camera, you can show the grading on the door, and you can just tell people that it's about the same size as the wavelength of light, and that's how it's protecting you from escaping microwaves and all. And that's it.
Excellent.
I'm here for it. Thank you. I'm trying to go back to the PC in the meantime. So there's going to be a small transition, I believe. Yep, right now.
He's going to the PC. If anyone has anything to add, I see a couple of things in the chat. And one thing I thought of when he showed me that in person is I'd love to take a microwave and make a hole in the metal mesh in front and compare how much you can light up the light with different size holes to show the idea of like it's a order of magnitude thing with the wavelength of the microwave radiation, how much will get through. But I don't have enough confidence in things yet to do that to a microwave that I own at this point. But something interesting to play around with. Other things anyone has to add? And anyone adds anything, just to mention Rute in Portugal will be the next one up. But anything for Erno in Hungary? Doesn't look like it. So thank you again, and now we'll turn over to Rute in Portugal. So it's great to see you again. Looking forward to your experiment, which, as people were showing up, you said you got from students at your science fair you had in June or the very beginning of July.
It was in June, in the end of June, because my kids they need to learn about light is the last chapter, and I told them, why not make a kind of science on stage for you at school. And so each group was presenting an experiment about light, and this is one. But this is in a small scale. They use a very big fishbowl, a big one. I will show you the link with the video that you can see it, but I'm just using bottles. So I have here a bottle. Can you see? It's not, I don't know why. Maybe I can remove something.
Are you using a virtual background?
No, I shouldn't. Do you know how to take it off? I'm sorry, because I don't want that.
Yeah, because sometimes anything that's not your face will get blurred, whether it's in front or behind.
Now
okay, so yeah, now you've removed it. So yeah, we should be able to see the bottle when you hold it.
Okay.
Yeah. Or the jar.
Yeah, this is a jar just with water, clear water. This one is water with a few drops of milk. And this is also water with more milk. So I don't know how this will be online here. Let me see if you can see clear. So what they will represent. This one is the moon, if we are in the moon with no atmosphere. This one could be at midday, lunchtime. Okay, so where the sun passes a part of the atmosphere. And this one, the one with much more milk, will be our sunset. Okay, so we have moon, midday, and sunset with no milk, with milk, and more milk. So the milk will be like the particles that we have in the atmosphere. And then I'm going to use my mobile, my flashlight. I hope that you can see. So in the moon, maybe it's not so easy. I should do this in a dark, in a black place. We shouldn't be able, but this is difficult to show, to see the light passing through the water. We shouldn't, but we could see the sun. I don't know if I'm clear enough. Yes? So this should be with no atmosphere, and we should not be able, but it's difficult to show you. So if this was black, you could not see the light pass through this flask, but you could see the sun if you were in the moon. Okay, if we use a bottle with a few drops of milk, this is like what we have in our atmosphere, we can see perfectly the scatter of the light. So I can see now in my screen that it's not possible to see what I'm looking here, that it's blue, a very clear blue. And you also can see the sun, but probably a little bit more yellow than the other one, a little bit. It's not very easy to show this on the screen, but you see here a little bit of yellow.
Yeah, it definitely comes through as more yellow from the two different angles, yeah.
Yes, okay. But it's a shame that you cannot see that here. Let me see more. No, it will be difficult. I can see a little bit of blue, not white, but I will show you the video, the link with the video that we do it in our school. You can see better the difference. And then in the end of the day, so sunset, you don't have more particles in the atmosphere. They are the same, but the lights will pass a big layer of atmosphere. And so you will see also a little bit of blue, but now, let me see. Oh, it's such a shame. Maybe I'm going to use another flashlight. Let me see if this one.
Not perfect, but it's visible.
Yeah. But if you were here, you could see exactly that it's orange. Okay. I can see now that online will be difficult. Or if I turn on the lights, do you think you can see it better? No, it's not easy to see. No, such a shame. No, you cannot see orange.
Oh.
No.
A little,
Oh,
a little. I see a little.
Oh, okay, okay.
How about if you shine the light through the bottom of the bottle, so it needs to go through the whole length of the bottle of the liquid? That, like, keeping the bottle vertical, would that?
Well, but here I can see it, you know. I think it's the like this. You can see orange, more orange here, and more white blue here. Yeah. Anyway, I can show you the picture that you can maybe easily see. Okay, let me show you. If it's okay, do I have the time to show you the picture?
Yeah, please do.
Yeah. So I'm sharing my screen. No.
Not yet.
Not yet. I will do it. So let me see. Where is it? Where is it? Oh God, I'm not. Oh, it's here. Okay. Yeah. Probably now I'm sharing. Yes.
Just starting to share. Yes, now we see it. Yes.
Okay, so I can show you the image. You see here, you can see easily the orange. And here you see the blue. Yeah?
Yeah, that's very clear.
Okay. So yeah, you can see it. This is a flashlight. So this is a fish. It's aquarium. I don't know if it's the name. Sorry, my English. So I
Yeah.
have here the flashlight. It's just water with some drops of milk. You can see very easy the blue, and on the other side, it's also easy to see the orange one.
Beautiful.
Yeah. And here it's also another image you can see. So at middle of the day, you will see the sun white, the light, and the sky is also kind of blue, very, very light. And in the end of the day, the sun you will look the light orange, because it's the only light that reach our eyes is the red, the yellow, and the orange. And the other one is, I think the word is scatter. And
oh yeah, scattering.
Yes, scattering. Yes, it's because the size of the wavelength. So the small wavelength, like the blue one, will be more scattered than the orange, yellow, and red. So, and that in the end of the day, because the sun will pass for a bigger layer of atmosphere, almost all the blue is scattered, and the only light that reach our eyes will be the orange. So this is a sunset in a glass of milk.
That's beautiful. Thank you.
Okay,
and
thank you.
And anyone who has anything to add or share on that, please jump in. One thing I want to mention, sometimes, especially if it's your first couple of times doing that experiment, one of the mistakes I made a lot of times is putting way too much milk, because you only need a couple of drops, and it's impressive how little you need.
Yeah.
And so, like, one thing that was handy for dosing it is if I made like a 10% dilution and then I was putting drops of diluted milk in. Or another thing that came up as handy was, often it would come up, we'd want to do that experiment or like use it for something one day for light, and then a week later, 2 weeks later, and not necessarily want to keep milk open, or like someplace I've been, we don't have a fridge. So sometimes powder is in handy for just use the amount that you need, and you don't need to deal with what do I do with the rest of a whole thing of milk. Although often it's the powdered milk isn't quite as good, because you don't have as many of the dissolved things that dissolve with as small particles. So it still works, but it's only if you want to avoid the problem of what do I do with the rest of the milk that I have open now. So that's the two things I wanted to mention for that. Does anyone else have anything to mention or ask?
I would like to add something. There's a way we have been doing, I guess, the same experiment, but with a bit of different setup, in a more chemical way. You have the fish tank, and you create a potassium thiosulfate solution or something like that, and then you have your chloric acid, something like that. I mean, I'm not really sure of the English names of the chemicals. And then you use these overhead projectors where you can put like these foil, something like this. You can write on it, and then you can put it on, and it will just get projected on the wall. And then you drop the chloric acid into the tank, and gradually, as sulfur just create or get created during the reaction, the solution gets more and more, oh god, milk-like. What's the word?
Like cloudy.
Cloudy, yes. I really want to use the scientific word, but it just escapes me. Oh, whatever. Cloudy. You know what I'm talking about. And so the picture of the overhead projector from this clear white becomes a bit bluish, and then gradually it looks like a sunset, becomes more and more orange and kind of reddish at the end, before the solution is so thick that it will just become black on the wall. And pretty much, I mean, I like to do that at the end of the class if I can schedule it that way, so I can send my students off with a sunset at the end.
Yeah, that's true. That's very, very nice. Thank you. And the only problem is the smell. I have to say that the smell is not good. And
Yep.
I can tell you that a very nice thing, if you do that with, you know, that paper that it's clear, a statue. So I think it's the name. You can put it on the top of that. You can have an image, and then you're just going to move and you will see the sun going down until the sunset. So we use that in a storytell in a classroom in a science fair. We talk a story, and then the sun will going down. Yeah, so you can, when, because it's clear, no one can see, and you're just talking, you know, and just, yeah. It's a very nice one. Thank you for the tip.
Just a minute. I want to try. I instead of the milk, I tried with the Dettol solution. It become a turbid. Dettol is the chlorobenzilol in a water. It gives the turbid, just like the milk. Can you hear me?
Oh yeah, we can hear well.
So it gives the same impression just like the milk, but it is a Dettol in a water. And then I put the lamp, and then we can see the scattering of the light. But I could not see the light blue or the orange effect. Yeah, it's really a good experiment. I tried just with the Dettol instead of the milk. I didn't thought about it. Nice idea.
And one idea, if the color doesn't come up with Dettol, it could be with the particle size, whatever is precipitating. I mean, I guess if it's precipitating from a chemical reaction, it should be small. But if it was bigger particles, you wouldn't have a separation because they need to be on the order of magnitude of the light that it's scattering.
Mm-hmm. Mm-hmm.
Otherwise, the way it would be scattered roughly equal.
Yeah, maybe. Yeah. Thank you.
Oh, thank you. Any other thoughts on those experiments before I switch over to myself for a wine-based experiment in Corsica? Well, a grape-based experiment. Doesn't look like it. Anyone has anything else to say? So I'll spotlight myself now. I'm going to take my microphone out just so if there's way too much background noise, let me know and I'll put it back in, and I'll just be a little bit restricted with this. But it's easier if I can move around. So just to give a bit of context as I'm setting for the experiment, I'll turn on my second camera and I'll be followed around for this experiment. So just a sec while I find the second camera. Okay, so now two beautiful cameras looking at me. So I'm at the Arena Family Winery, and I'm just going to show this wine press because my experiment is to model what happens inside of a wine press. So this is a wine press that was running with grapes that we picked this morning with the tractors over there and the trailers behind. From not that parcel there, if I go around the tree, you can see at the base of a mountain, the sun is kind of blocking it. But by about 9 in the morning, we were in the direct sunlight and it was uncomfortably hot. So just over these vines and on that kind of mountain there, you can see a bare patch towards the left. And then if you go diagonal to the right from that, we were in that patch there picking the grapes there. And it's a lot steeper than it looks from here. Anyways, back to the actual experiment at hand. So to look at pressure and how pressure affects a grape based on the grape's anatomy. So I've got a bunch of grapes. They're actually red grapes because we finished picking the white grapes this morning, and you usually wouldn't press red grapes immediately, but the basis for the experiment still stands the same. So here's a bunch of red grapes, and I've just filled a cup with them. And what I'm going to do is just put another water cup on top of the first cup and crush it with different amounts of weight. And with a couple of simple calculations, look at what pressure that corresponds to. and how that matches what goes on inside the wine pump. But before I get to that part, I'm going to take a single grape, and can you zoom in on the frisbee here for the single grape? And I'm just going to cut it open to look at the anatomy of the grape. So it's a little bit of physics, a little bit of agricultural science, or maybe biology going on here. So we see in each half of the grape, and if it's not zoomed in enough or if it's not clear, just let me know. But ideally with a microphone rather than with the chat, so I don't need to look back and forth to the chat. And so you can see this half. I'm just going to pull out the seed. And the seed isn't just a like hard part on its own. You can see it looks kind of translucent. And it's a double layer of cells around the seed that protects the seed. Because that's where all the genetic information, like the seed is what can allow a new plant to grow. So it's kind of the important part of the fruit. So we have a layer of cells there. Then in the mass of the fruit, we have the pulp, which at maturity, the cells are actually bursting. So they get filled and the osmotic pressure is enough that it causes it to rupture, and you'll have juice that relatively freely flows. We see most of it still held in the cells until I squeeze it a bit, because it's still within the cytoplasm, but the cells are kind of like swollen up, ready to burst apart. And then near the skin, and we'll see this more once I start pressing it, but if I kind of turn it inside out, we see there's this like soft layer I can kind of scrape off. And then we have a harder layer of cells that, again, just like for the seed, that last layer of 1 or 2 cells matures slower, or it stays more rigid. It's also a smaller cell size. Next week, I may or may not try and stain it and look at it under the microscope. It's really hard to see transparent cells under a microscope. You need to dye them. And I didn't think to procure dyes to dye cells in Corsica. So we'll see how that goes. But the important part to retain here is on the seed and next to the skin, there's a tougher layer of cells. And in the middle, the mass of the grape, it's got a softer layer of cells that are planned to be that way. It's like that in most fruit as well. And they're like bursting or ready to burst at maturity, ready to free up the juice. So at fairly low pressure, we'll first get juice out of that pulp layer, and it'll only be at much higher pressures we get any juice coming out of the epithelial cells just on the inside of the skin, or the seed packet cells. So a couple of calculations to give context to what's happening inside the cup. Fairly simple. It's like grade 7 physics or so, maybe grade 9 in a lot of places, but like it's not tough stuff. So the first part is just that pressure is a force over an area, and the units that they use on a wine press typically are bar, and a bar is 1 Newton per centimeter squared. And if we're talking about pressing down with the force of gravity, if we accept G is about 10 Newtons, then we have about 1 kilogram per centimeter squared. This specific cup that I'm using, it measures 5.5 centimeters across the bottom. The rest of the cup I don't care, because I'm just using the bottom to crush the grapes, but that's upside down. But I measured ahead of time. Trust me, I can use a ruler or a tape measure. About 5.5 centimeters. And so the area will be about 25 square centimeters. So that means that for each kilogram I put on my model wine press, I'll get 1/25th of a bar of pressure, or 0.04 bars of pressure. So this chart, which I'll point back to every once in a while, and I'll put on a rock, put a rock on it to keep it still so it doesn't fly away. That'll give our reference pressures. So then to actually load it up, I'm going to turn this and move my laptop as far away as possible in case I drop a bucket of water. I almost did that while practicing this. So here's the glass. I'll try and unclutter the table so it's kind of clear. Grapes out of the way, kind of. Paper out of the way. And can you zoom in nice and close on the glass? And we'll have like the second camera being the overall view for that. And then this is one of the buckets we harvest the grapes in the morning. And so I'm just going to put the bucket on top and move things even further away from my computer in case. Bucket on top, and I'm just going to start with a 1 liter bottle of water, which should weigh pretty close to 1 kilogram, plus or minus the plastic or a filling error. So that'll be about 0.04 bars. And we see it's starting to push down on the grapes. There's a tiny bit of juice coming out, but not much interesting going on. Adding another bottle, this time a 1.5 liter bottle. We drink a lot of water, it's hot here. That brings our pressure up to about 1 bar. And we see it's just starting to liberate the first juices. And if we move it around and inside the press, it'll squeeze the grapes and then unsqueeze. So the pressure is changing. So if we put it on and off, and like mixed and turned it around, we get a couple of drops coming out, but really not that much yet. Now I'll bring things up to about 0.4 bars. For that, I need 5 kilograms of water. So just going to fill this bucket. It's a 16 liter bucket. There's lines on the inside. Just trust me, I'm filling it to roughly 5 liters full. So with 5 liters, we should be bringing things up to about 0.4 bars. And that's where it really starts, like that's the minimum amount for it to get a lot of the pulp's juice out. It's still not crushed that much. If we looked into a bit more like plant anatomy and what's happening to the grape at maturity, that layer of cells is the highest in sugar. So from the first part that comes out of the press, you'll have a slightly higher sugar content from the rest. And this is actually the pressure at which the boss this morning pressed the first grapes when we had 1 trailer full to make room in the press for the second one. Let's see if we double that to 0.8 bars. And actually I got the units, well, not the units, the amounts wrong. This is 0.4 bars, which makes a lot more sense for it actually crushing. We see some of the pulp that looks kind of greenish coming out there. And as we move it around, we're getting a decent amount of juice, but this will be exclusively from the pulp. We won't get any epithelial juice. So it'll not only be slightly higher sugar content, kind of lighter aromas. If we look at what's happened to the grape itself, as predicted, the mass of the pulp is kind of everywhere, like the pulp's being crushed. And if it's crushed several times, like if we keep going with that pressure, we can get most of the juice from the pulp away. But the epithelial layer there, we still have a slippery layer of cells and the seeds still fully protected by a packet, like the pack of cells there. And now we're going to up the pressure even more. This gets hard to model, but I'll put about half of my weight on this. This is very approximate here, but going with about 40 kilograms of weight pushing down on that. That's the pressure that the press was using for about 4 or 5 hours. He had it in there, I think, from when everything was in and it got up to full pressure. And we see that's enough now to liberate the juice from most of the grapes. And we can see we have like a layer of juice up top, the grapes down below. And if we pick one of them out, and if we repeated that like in several different directions as the press does, we can hopefully imagine we'd get most of the pulp pushed out. We get eventually the seeds, yeah, like this one, without too much work on my part, got most of its outer layer of cells off, so maybe just on the tip there. And if we continued that for several hours, we'd get most of the juice out of these grapes. I have over here an example of some that came out of the press just about an hour before we started the Zoom. And so after several hours of that pressure draining off the juice as we go, we get like these flat, what's remaining, and we can look in there. We can see there's still a little bit left, because if you crush things completely, you get some more bitter aromas from the last juices of the epithelial and seed cells. But it's gotten most of the juice from most of the parts of the grape there. And of course, if we want to make rosé, we just leave this in contact for 6 to 24 hours or 6 to 30 hours. We see the juice is already getting a bit pink just from the skin contact for using red grapes. And to make a red wine, we'd leave it in contact with the skin about 2 weeks. It really depends on how dark you want it and what kind of wine you're making. Things that go beyond the science of a wine press. So that was that experiment. I guess I'll sit back down in front of the laptop. Didn't spill water on it, but that was that experiment to like relate grade 7 to 9 pressure to what's actually going on inside of a wine press. I mentioned in the emails I'd sent out, I'll be having a spotlight experiment share where I'll be sharing a handful of other like wine or grape or viticulture based experiments. Next week, hopefully Wednesday at 6. I still need to confirm availability because hopefully I'll be in the cellar for part of it, but not 100% sure. But I'll send an email about that. That being said, that was my experiment. If anyone has any questions on that or any questions for anything we've seen or any announcements they feel like making, please jump on and say that now before we close things up. Doesn't look like anyone has anything to say. So with that, I'll say thank you everyone for joining in this experiment share. Oh, I guess people will be curious when the next experiment share that isn't just a wine spotlight is. I'm not sure. I need to check with Gordana, who's on the call. It might be fun to do it when I see her in Požega right at the very end of September. So that's a possibility. I'll discuss with her, and then once we decide things, I'll send out an email with the date and invitation and things like that. So with that being said, thank you again, everyone, for joining. Have a great rest of the day. And hopefully I'll see you next week for the Science in the Cellar wine science special one with a couple of experiments I'll be working on in the meantime. Have a great evening, everyone.
Michael, thank you so much. If you come to Portugal, I will have one like this if you would like to try.
Oh, perfect. I definitely will come to Portugal to see you at some point.
Yeah. Portuguese wine from Alentejo. This is a good one. So this will stay here until you come.
Oh, excellent. I'll need to come with you within the year then. I'll let you know when I figure out when I'll have time.
Thank you, Michael. Thank you, everyone.
Thank you, everyone. Bye.
Thank you. Thank you.
Bye, everyone.